Hey guys, so today I'm going to give you some tutoring over Unit 4, Lesson 1, and go through all of the problems that are kind of application problems. So this lesson is on determining kind of the charges and the names and the formulas for ionic compounds. And so one thing that you will need is this list of the ionic charges of elements. I have this list in my student resource folder, and it's just in the main folder, and it's called Ionic Charges of Elements. And so you can pull this up in the student resource folder, and I can also include a link to that in my YouTube section. So if you click on like the detail section, I'll include the link to that as well. You're going to need this charges list, which tells you the common charges of elements. So just looking at this table just to get a feel for it, notice that this section is skipped. These are called transition metals, this intersection right here. And transition metals typically have multiple charges. So they might have a +1 and a +3 charge depending on the situation. And so we'll talk about that later. But generally, as you go across, you can see the trend and the charges, and we'll come back to that. When you have an ionic compound, there's a certain way that they're named. So let's look at this example right here. Let's say that you have SR3N2, and I ask you to name it. Well, first of all, we have to decide, okay, is this an ionic compound? An ionic compound is a metal as the first one and a non-metal as the second one. So is SR a metal and is N a non-metal? And I have a list of metals and non-metals that I actually need to provide, but all of the examples here are going to be yes, they are. But I will actually pull that up as well for the list of metals and non-metals. Give me 1 second. My list of metals and non-metals is also in my student resource folder. And so you can always double check whether or not something is ionic or covalent by pulling that up. Okay, so the first thing we need to figure out is this an ionic compound? And so basically for ionic compounds, the first element is a metal and the second element is a non-metal. So we have to ask, is SR a metal and is N a non-metal? You can find this by looking here. I have this also in my student resource folder, but if you find SR, which is right here, you can see that it is a metal. And then N over here is a non-metal. So we do have an ionic compound if you ever want to double check. The way that ionic compounds are named is you literally just write their name out. So we find SR on the periodic table. SR is right here. And if you zoom in some, you may have to zoom in a lot to see it very well here. But SR's name is strontium. You can kind of see it written right there, right? And then if you scroll over to here, N's name is nitrogen, okay? So the way that you name it is you find their names and you write them out. So strontium and nitrogen, and then you change the ending of the second one to "ide." And so the name of this substance is going to be strontium nitride, okay? That's generally how ionic compounds are named, just the metal name and then the non-metal name, but you change it to "ide." But on your quiz, you'll see that there are two ways to name things. One is called systematic and one is called stock. And so this is kind of how you name it with the stock system in mind. And then systematic, you don't really use systematic in real life for ionic compounds. So I'm not really sure why that's It's not something that's normal is to name it systematically, but I will also show you later how to name it that way, just so that you can do well on the quiz. So also let's look at this next example. What if you have to name something like this, where it's like, what is this compound right here? What you'll need to name this compound, you notice that there is Ba, which I can find on the periodic table. Ba is right here, right? So I can figure out its name. Ba is right here, and it's barium, okay? But what you'll notice is that the second substance is multiple together, right? NO3. What you'll need for this is your polyatomic ion list. This is also in the student resource folder. Anytime you have multiple elements together within a parentheses or just 3 elements or more, you can find them on your polyatomic ion list. So if I scroll down, I can see it right here. This is the ion that was there. That was NO3, right? So the name for that is nitrate. So because NO3 is right here, this is its name right here. And so going back, I know that this is called nitrate. And when you have a polyatomic ion, which is multiple ions that behave as a family unit, you'll see basically if there are 3 elements, Ba, N, and O, you just name it the way that it is. The name on that sheet was nitrate. So you don't need to change the ending to "ide" or to anything else. You're just going to name it the way that it is there. So that's how you name polyatomic ions. And then the last situation here would be if you have a transition metal. So if you have a transition metal, we're going to go back and find it on our periodic table here. So here is Fe, and here is O. Notice that Fe is a transition metal. When you have a transition metal, you need to include Roman numerals to indicate the charge, okay? So for Fe, we know that's iron. For O, that's oxygen. Notice that O has a -2 charge, okay? So O has a -2 charge. Because O has a -2 charge, iron is going to have a +2 charge in this situation because the net charge of an ionic compound is always 0. So the transition metals, you kind of have to work backwards and figure out, okay, the other one had this charge, and so the transition metal will have the opposite of that, or this charge here. And then you put it in parentheses as a Roman numeral. So because iron's charge is +2 here, the name will be iron 2 oxide. So look out for that on your quiz. When you have a transition metal, you need to choose one that includes Roman numerals that tells you the charge of that metal. And I will give more information on that later, but this lesson doesn't focus heavily on transition metals. So you can always come and talk to me about it if you come across one and you need help with it. So let's actually go through the problems now on here. It says the correct way to name a copper cation with a charge of +2 is blank. Well, let's find copper here. You see how copper is right here? Copper is a transition metal. Remember that these are all transition metals within this kind of rectangle right here. So everything in this section is a transition metal that I'm highlighting here. So copper is one of those transition metals. So copper will need a Roman numeral to indicate the charge. And because it says that its charge is +2 in this scenario, the Roman numeral for that is this. That's the Roman numeral for 2. So copper should have a Roman numeral of 2 because it's a transition metal and we know that the charge is +2. For problem number 8, it asks you to fill in the information here. You will have a quiz question just like this, so make sure you get it right. That way you can refer to it when you take your quiz because you can use open notes on your quiz. So we need the ionic formula for aluminum. So we're going to go back and find aluminum here. Aluminum is right here. Its charge is +3. You see how aluminum's charge is +3? So the ionic formula will be Al with a +3 charge. And the charge is +3. Okay? So the ionic formula, you just list the element with the charge, and the charge is going to be the same number as that. Okay? So now let's fill it in for here. So we have barium. We need to go find the symbol for barium. Barium is right here. If you zoom in, you can see that it reads as barium. Barium right here. Barium has a charge of +2. Okay. So the symbol is Ba, and the ionic formula is Ba2+, and the charge is +2. They're always going to match there. Okay, what about Ca? We need the name for Ca. So we got to go back to our periodic table here and find that name. So zooming in on, oops, I did the opposite of that. Zooming in on Ca, the name for Ca is calcium. So this is going to be calcium. And then what charge does calcium have? Calcium has a +2 charge. It's in the +2 column. And so it's going to have a formula of Ca2+ and a charge of +2. Okay. Last one, we need the symbol for that. And we can kind of look right here. Like, look, it already, like you can figure out what the symbol is going to be. It's going to be K for potassium. And the charge for this one, it already tells you what charge it has. It's just going to be +1 because it's just K+. So that just means that it has a +1 charge because it's not listing anything else. Okay, so looking at this next one, I'm going to have you guys do problem number 9. I think that this helps you understand it a little bit more. So try number 9 on your own, and you can refer to the ionic charge list. You're going to need this right here. And you just look up the charge of the element and you fill it in. And you may need to look up the name. Like for this one, you have to look up the name of it. What's the name for Na? But yeah, so try number 9 on your own. Number 10 as well, you can try on your own, except these are negative charges. It's the same thing, but it's on the other side. So like chlorine, we'll do one together. So for Cl, let's go find that on the periodic table. So finding Cl right here, this is Cl. Its name on the periodic table is called chlorine. Okay, so looking right here, the name is chlorine. And it has a charge of -1. So going over to that, chlorine has a charge of -1. So its name is going to be Cl with a -1 charge, and its charge is -1. The only thing is that if you noticed, it ended in "ene" and they change it to "ide." That's what all of the negative charged ones do. Their name on the periodic table changes to "ide" at the ending if it has a negative charge. So chlorine becomes chloride, fluorine becomes fluoride, nitrogen becomes nitride. So just keep that in mind. That's why the name is changing there. But you can fill in the rest. Like for this one, go find this element on the periodic table. It came from fluoride. And so you're going to look for fluorine on the periodic table, fill in the symbol, fill in the formula, and so on. Now we're going to talk about writing formulas. This is a little bit different, okay? So what you need to do when you're writing a formula for an ionic compound is find, first of all, we need to look up their symbols. So we need to look up the symbols of these elements. So let's do that for lithium and bromine. What is the symbol for lithium and what is the symbol for bromine? Go to your periodic table and find it, and then pause if you need to until you can find it. So looking here, here's lithium, it's Li, and here is, what did I say the one was? Bromine. So it's Br right there, Li and Br. The next thing that you do after that, so it's Li and Br, is you plug in their charges. Okay, so let's go back and look up the charges for Li and Br. Li has a charge of +1 and Br has a charge of -1. Okay, so +1 and -1. The second thing that you do is you cross over the charges. You cross over the charges. So the Br right here, I'm going to circle it, has this charge. You take the number, just the magnitude, not like the positive or the negative, and you cross it over like this. So the formula is going to be Li1 Br1, which is just Li-Br. The reason for that is because the net charge has to equal 0, okay? So because it's +1 and -1, they're just going to cancel out, and it'll be Li-Br. crossing over ensures that the net charge is equal to 0. So let's try it for calcium and chlorine. So we need to find the symbol for calcium and chlorine and the charge. So going back to this list right here, you can see that the calcium is right here with the +2 charge. Chlorine is right here with a -1 charge. So I'm going to write those down. So calcium has a +2 charge and chlorine has a -1 charge. So now we need to cross over again. Basically, we need the net charge to equal 0. And right now it doesn't, because one of them has a +2 charge and one of them has a -1 charge. And so to ensure that the net charge equals 0, we're going to need 2 chlorines, right? Sorry, I should have the charge like this, because then this would add up to -2 and that one is +2, right? And then it would equal 0. So when you cross over, you're kind of doing that. So I'm going to circle the 2 and circle the 1, and those numbers cross over. My formula is going to be CaCl2 or Ca1Cl2. The 2 goes over here. I'm saying that I need 2 chlorines to match that calcium, the charge of the calcium. Because calcium had a +2 charge, I'm going to need 2 sets of chlorine to match that, because each chlorine has a -1 charge. So CaCl2. For this next one, I'm not going to go look it up, but you can pause the video and find the symbol and the charge. So barium has a charge of +2 and oxygen has a charge of -2. So we can cross over here. Again, that would go here and this would go here to make Ba2O2. But because they're both the same number, we can reduce it. So they're both 2 and 2. Those are both divisible by a whole number. And so we're just going to reduce this to BaO, because basically the charges cancel out, 2 and -2. So we don't need to do anything fancy there. The charges already cancel out. Okay, let's look at the next one here. For here, we need to write the name. So I'm going to do a couple with y'all. So remember, for the name, you just write their names out and change the ending to "ide." So go find Mg and find Cl on your periodic table. So go back to your periodic table and find Mg and Cl, or look up a periodic table online and find it. You can go to ptable.com and look it up. Mg is magnesium and Cl is chlorine, and you change the ending to "ide." Okay, so the name of this substance is magnesium chloride. Okay. By the way, this is how you would name it with the stock, kind of like with the stock system. There's 2 ways that they teach you to name it, but the stock system is really the only way you name it in real life for ionic compounds. Ki, go ahead and pause and find these elements and try to figure out the name. K is potassium, surprisingly. And I is iodine, if you find on the periodic table. And the ending changes to "ide." And so the name of this is going to be potassium iodide. Iodide. For this next one, Ca is calcium. And N is nitrogen. And so the name is going to become calcium nitride, because remember, you change the ending to "ide." Hopefully this is kind of making sense on how we're naming here. And if it's not, then just come ask me about it. This is asking you to look at your polyatomic ion sheet. So it's asking you to make a formula out of this. So for sodium, let's look at one example together. Sodium is Na on the periodic table, and it has a +1 charge. If you go over and find sodium, it's Na with a +1 charge. Nitrate, if they end in 8, see how these all end in 8? That means that it is a polyatomic ion that we have to look up. And so looking up nitrate right here, nitrate is NO3 with a -1 charge. So I'm going to write that down. Nitrate is NO3 with a -1 charge. So when you cross that over, the formula, it's just going to be 1 to 1. So it would be Na1, NO3, 1, right? Or just NaNO3. For carbonate, Carbonate is CO3 with a -2 charge. You could look this up by Googling it, or you can look it up on your polyatomic ion sheet. And magnesium has a +2 charge. So again, these are going to cancel out. And so our formula would be MgCO3 and so on. I'm going to have you guys try these last two. Again, look up the whole polyatomic ion there and the whole polyatomic ion here, and then cross over your charges. And if you have any questions at all after you do this, please join my classroom and I'll be really happy to help you. This is kind of a complicated subject, and so I expect that there will be some questions, and I'm really, really happy to help you. Have a great day.